So today we're going to be talking about exponential functions. It's a function that can be described by an equation of this form, y equals a to the x, but we have some restrictions. A has to be greater than 0, but it can't be equal to 1. So graph y equals 4 to the x. We're going to state the y-intercept, and we're going to use the graph to determine the approximate value of 4 to the 1.8. So let's see if we can make a little table here, and then I have my graph on the next slide. So if we were making an xy table, and again, usually we start with 0. So what is 4 to the 0 power? Well, anything to the 0 power is 1. Whoops, I don't want to put 4 in there. Thinking ahead already. Probably next most obvious to put a 1 in. So what is 4 to the first power? 4. If we had put a 2 in, 4 squared is 16, so we're going to have a little trouble graphing that now. Probably need to put negative number in, so I guess I'll just continue my table over here. So think back to what we learned. What is 4 to the negative 1 power equal to? Well, it's 1 over that to the positive, so it is 1/4. What if we put a negative 2 in? So 4 to the negative 2 is 1 over 4 squared, which would be 1 over 16. So now we're going to take these values and graph them. And again, it's going to try to be kind of hard to be too exact here, but let's see what we can do. So 0, 1, 1, 4. That's about the only points that we'll really be able to graph accurately. 2, 16, so that's going to be way up there somewhere. Negative 1. 1/4 is just going to be barely, that's too much, but I can't hardly do it with this. So this function's a little bit different, and then it's going to be like coming down like this, and then it's going to be curving, but it's never going to actually get to the 0. It's going to keep getting smaller and smaller, but it looks like that. So kind of a little different looking. So what was the y-intercept? That was one thing they asked us to find. So the y-intercept is 1. And then approximate from the graph, and again that's really hard with my marker, but 1.8. So here would be about 1.8. So if we go up here, somewhere right in this area, so what would that be? 1, 2, 3, 4, 5, 6, 7. So it looks like ours would be something like close to 7, but that's not really very accurate. So our approximation is 7. Now to do this in the calculator, you want to use your y to the x key or whatever, so we put in 4, hit the y to the x key, and then put in 1.8, and we get that rounded to the nearest tenth. It is 12. So 4 to the 1.8 is actually equal to 12.1. So not a lot of accuracy, but do what we can there. Alright, graph this, state the y-intercept, use the graph to find this. So again, I don't think I added a graph, so we might have trouble there. Alright, hopefully the graph will be there. I just went back and added it to the screen. Alright, so again, y equals 1/2 to the x power. So if we make our xy table, logical thing to put in, it would be 0. Anything to the 0 power is 1, so keep that in mind. That's a little strange again. If we put in a 1, we would get 1/2 to the first power is 1/2. If we put in a 2, 1/2 squared would be 1/4. Let's put in a negative 1/2. So 1/2 to the negative 1 power would be 1 over 1/2. But what is 1 divided by 1/2, really, which is another way to read that? That's 1 times 2 over 1, so that is actually equal to 2. And if you put in a negative 2, you're going to get 4. So those are some of the ordered pairs that we want to graph here. So let's go to the next slide and graph. So again, we have 0, 1. We have 1, 1/2. We have negative 1, 2, we have negative 2, 4, so the graph is going to come down something like that. Again, hard to kind of graph very accurately, but I'm doing it. So it asks us to find the y-intercept, which in this case is 1. And we were supposed to find 1/2 to the negative 2.5. So I didn't really graph it very far. 2.5 looks like it's about 1, 2, 3, 4. Did I do that one wrong? 1, 2, 3, 4. Yes. Oh, there it is. So it'll be about 5. Going up kind of like that. So 1, 2.5. So about 5. So we'll say this is about equal to 5. If you put it in your calculator, so I probably want to use 0.5, y to the x, negative 2.5. You're going to get 5.66, so 5.7 is our approximate value.